Welcome to the video for Lecture 14, Section 1. This video is an introduction to temperature measurement. This is the first lecture of several that will deal with instrumentation topics. This first video will be an introduction to both the general area of instrumentation and to temperature measurement. The instrumentation field is big enough that it could be the basis for a course itself. But not all of you need that much information to become an instrumentation specialist. So the goal in this class is to teach you principles that you can take and apply to any instruments that you end up working with as a professional. We will cover a few representative sensors with the concept that if you understand the principles behind them, that you can figure out other sensors too. The instrumentation topics that we will cover over the next few lectures include temperature sensors such as thermocouples, resistance temperature detectors, thermistors, and integrated circuits. We will also talk about strain gauges and Wheatstone bridge circuits. So our agenda for temperature measurement lecture 15 includes information about temperature standards, scales, properties used for measuring temperature, and 4 electrical-based methods for measuring temperature. Temperature is a fundamental measurement quantity like length, mass, and time. It is based on a thermodynamic temperature scale with absolute thermodynamic 0 and 0 Kelvin and a triple point of water at 0.01 degrees Celsius. Remember that the triple point of a material is when the material is at gas, liquid, and solid forms at the same temperature. There are other defined temperature points including water boiling at 100 degrees Celsius at 1 atmosphere pressure. The International Temperature Scale of 1990 defines over 15 different calibration points for from minus 272 to 1085 degrees Celsius. Many of temperatures based on the triple points of different chemical elements. The National Institute of Standards and Technology promotes U.S. innovation and industrial competitiveness by advancing measurement science, standards, and technology. One of the things that NIST does is provides calibration references for many different measurements. When you buy an instrument, you can spend more to have it calibrated with equipment that is NIST traceable. With NIST, there is a thermometry group that creates, maintains, and disseminates capabilities to measure temperature and humidity traceable to NIST standards. For more information, go to the website in the course packets. This slide shows 4 temperature scales. There are 2 absolute scales, Kelvin and Rankine. The common English unit scale is Fahrenheit, and the metric scale is Celsius. There are many different ways to measure temperature. This slide shows 3 ways to measure temperature based on thermal expansion. The devices are pretty simple, easy to use, and portable. Mercury used to be used in liquid in glass thermometers, but mercury spills from broken thermometers posed environmental and safety risks, so they were replaced with safer options. Liquids used can include pure ethanol, toluene, or kerosene, depending on manufacturer and working temperature range. Since these materials are transparent, the liquid is made more visible by the addition of a red or blue dye. Bimetal temperature sensors are generally quite rugged, but they tend to be less accurate than many of the other types of temperature sensors. The principle of operation is based on two metals with different thermal coefficients of expansion connected in a way that the pointer on a dial indicates the temperature. Again, they are simple, rigid devices, but are not very accurate. Pressure-based temperature sensors are based on the ideal gas law, where the temperature change produces a pressure change that is used to indicate temperature. I just want you to be aware that these types of sensors exist. We are going to spend more time talking about thermoelectric thermometry or thermocouples, resistance temperature detectors, commonly called RTDs, thermistors, and integrated circuit thermal transducers. Here is a table listing 4 electrical properties and the corresponding temperature sensors. Thermocouples are very common temperature sensors because they are inexpensive and rugged. The wires and the equipment used is fairly well standardized. You have used the thermocouples in lab. A thermocouple junction generates a small electromotive force or voltage that can be measured and calibrated against the temperature. Resistance temperature detectors are fairly common too. They are based on the fact that the resistance of some metals depends on temperature. The resistance change is quite small, so a Wheatstone bridge circuit is used to convert the resistance change into a voltage change that can more easily be measured. It turned out that the platinum was a good metal to use in RTDs for both its resistance characteristics and its stable and corrosion resistance. For most metals used in an RTD, the resistance increases as temperature increases. Another category of temperature sensor is the integrated circuit thermal transducers. They are based on semiconductor technology, and what is great about them is that they generate linear outputs in proportion to the absolute temperature sensed. At this point, the temperature ranges are limited, but the linear response makes them much easier to connect it to standard data loggers. You will see some in temperature lab. This slide brings me to the end of the lecture 14 section 1 video. The next video will cover thermocouples in more details. Please write down any question you have and bring them up in the class or lab. Thank you.